Hello, I'm covering section 14.2 on measures of central tendency. How to measure the center of a distribution, and the measures of central tendency I'm covering are going to be the mean. Let's keep the numbers, the mean, the median, and the mode. Two most important ones are the mean and the median. The mode is mainly for qualitative data. So there's a notation I will be using for summation, or that the book uses. The book uses the Greek letter sigma. So I'm writing this because I don't know how to type Greek letters in this board. So the Greek letter sigma denotes summation or indicates summation. And the first measure of central tendency to denote the center of a distribution is going to be the mean. Okay, the mean is what we know as the average of a set of data values. I need to find the page. Guess what we know at the average? We add all the values and divide by the total number of values. Okay, so I'm waiting for this book to open, and here it is. So that's how you compute a mean, the mean of a distribution. If a data set contains n data values, then the mean x bar of the data set is the sum of that is the sum of all data values over the total number of values. So with letter, this is going to be the sum of all data values, or I'm going to call it x bar. The sum of all data values over the total number of values. Okay. Here's the first example. On the same page, that's the quiz yourself. We're going to find the mean of a data set. So that shouldn't be very difficult. For the data set 9, 12, 22, 6, 5, 15, 12, and 25, we're going to find the sum of data values, the number of data values, and the mean. Okay, the sum of the data values, that's going to be 9 plus 12. We add these numbers. And the sum is 106. It won't take you too long to see that there are 8 data values. So the mean of the set is the sum of all data values over the total number of data values. That's 106 over 8, or 13.25. And that's it. If you have a frequency distribution, you also need to consider the frequencies. So that's the next quiz yourself. So that's not the book. Okay, so that's the problem I'm doing, but I'm doing the so I'm doing the quiz yourself 5 on page 736. The mean of a frequency distribution. A paramedic service kept track of the number of calls per day that it received over a 2-week period. Use the information in the table below to find the mean number of daily calls over this period. Okay, so if we're going to find the mean, now we have frequency, so that's going to be 4. So the first entry is going to be 4. And then it's going to be 5, but 5 appears 4 times. So that's going to be 4, and then plus 5, plus 5, plus 5, plus 5, plus 6, plus 7, plus 7, plus 8, plus 8, plus 8, plus 9, plus 9, plus 10, divided by the sum of the frequencies. That's going to be the total number of data values. So the mean is going to be 4, which appear once, plus 5 plus 5 plus 5 plus 5, or 5 times 4, plus 6, plus 7, plus 7 plus 7, plus 8 plus 8 plus 8, plus 9 plus 9, plus 10. And the total number of data values is going to be the sum of frequencies. Okay, and the mean, so what is that? This 4 plus 20 plus 6 plus 14 plus 24. Let's write this. That's 4 plus 20 plus 6 plus, so that one is plus 6 plus 14 plus 24 plus 18 plus 10. And there's a total of 14 data values. So at the end, the mean is 96 over 14. If you keep it as a fraction, the fraction reduces to 48 over 7. But most of the time, it's going to be a decimal. So that's going to be approximately 6.86 calls per day. So in general, I'm just going to read this. There's no need to copy the entire formula. But when you compute the mean of a frequency distribution, you need to consider the frequencies. First, write all the products of the value and the frequency in a new column. I mean, you don't need to write a table for this. Then represent the sum of the products that you calculated by the sum of the value times the frequency. Also, add all the frequencies, and the mean is going to be the sum of the value multiplied by its frequency over the sum of the frequencies. Now, there's only one problem with the mean, that it can be misleading. So here's an example of a misleading mean. So consider the following list of salaries. Let's say that the president of a company makes $300,000, and 4 workers earn $50,000 each. So the mean salary is going to be So we have a frequency that's going to be 300,000 plus 50,000 times 4. Each of the workers that make 50,000, and there are five employees or 5 people working for this small company. 300,000 plus 50,000 times 4, that's 300,000 plus 200,000 over 5. So at the end, the mean salary is 100,000. Which is not a reflection of reality, because 4 of those 5 people earn half the mean salary. So the mean is not a good indicator of what is happening in reality. So the mean salary of 100,000 is misleading. And the reason is because the value of 300,000 is an example of an outlier. If you take MS 205, you're going to see how to determine outliers. But usually an outlier is a value that is significantly larger or smaller than the rest. And in MS 205, if you take Introduction to Statistics, you'll see exactly how to determine an outlier. So because the mean can be misleading because it is affected by outliers, it is good to consider other measures. It is good to consider measures of central tendency other than the mean. So we cannot rely entirely on the mean. We need to consider other things. The next measure of center is the median. So if you have a set of values or a frequency distribution, it's good to consider both, not rely only on one, but to consider both measures of center. And the median is going to be the value in the middle. That's it. So if you want to compute the median, you need to compare, you need to sort the data either in increasing or decreasing order, and the median is going to be the middle value, or you have an even number of values, is going to be the mean of the 2 middle values. So if we arrange a set of data values in increasing or decreasing order, the median is the middle value in the list of values. However, there are 2 cases to consider. If there is a known number of values, the median is the value in the middle. So let's say you have 5 values, 2, 5, 7, 8, and 10. The median is going to be 7. And if there's an even number of data values, actually, maybe I should give this. So that's the median. And if there's an even number of data values, let's say 1, 4, 6, 8. Yeah, the data must be in order. 14, or 11, 13, and 14. Well, actually, I just need 6. The median is going to be the mean of the 2 middle values. So the median is going to be 7. That is the value, the mean of 6 and 8 is going to be 7. Okay, so we're going to do an example. And the good thing about the median is that it's not affected by outliers. So unlike the mean, the median is not affected by outliers. So I could have another value. I could have I could have 99, and the median is still going to be 7. It's going to affect it's going to significantly affect the mean, but the median is not going to change. Okay, so I'm going over example 4. Here's a list. So, well, actually, you have a table. Says that the problem says that, well, the situation says that when Barack Obama was campaigning for president, some political observers thought that he was too young to be president. In example 4, we investigate how Obama's age compares to that with that of other 20th and 21st century presidents. Okay, so the table on the left lists the ages at inauguration of the presidents who assumed office between 1901 and 2017. Find the median age for this distribution to see how Barack Obama's age at inauguration compares with that of other presidents. And you can see from Ted Roosevelt, every president elected since 1901, from Ted Roosevelt all the way to Donald Trump. Okay, so let's, so we have all these edges. What I'm going to do is arrange the edges in order. So for this matter, Barack Obama was 47 when he took over. And actually, you can also see that Ted Roosevelt was 42, and and John F. Kennedy was 43. But most of them were people in their 50s or 60s. Usually, a president must be someone. Well, they want someone with enough experience, but also young enough to have the energy to hold that position. Okay, so the table that I showed you lists the ages at inauguration of the presidents who assumed office between 1901 and 2017. Find the median age for this distribution to see how Barack Obama's age at inauguration compares with that of other presidents. So there was a list of 20 presidents. We are going to write the ages in order. So in order, those are 42, 43. Yeah, I'm going to write all the ages in increasing order. And we are going to determine the median. Okay, so those are the first 10 and the next 10. Most of them were people in their 50s or early 60s. Actually, the oldest of that group was Donald Trump until Biden. Okay, so there's a total of 20 values. So the median is going to be the mean of the 10th and 11 values. So you have the two middle values, the 10 value and the 11 value. and the median, or let's keep that. The median since you have 20 values, that's going to be the mean of the two middle values, the 10th and the 11th value. So that is going to be 54.5. If you have a node number of data values, then the median would be the middle value. So let's suppose that we add Joe Biden. So if we add Biden to this list, Biden, when he took over, was 78 years old. Who was 78 years old when he assumed office. So we're going to have another value. We're going to have 21 values, and the median will be the 11 value. So the median, just pick the middle value, and the median is going to be 55. And actually, Biden, at this moment, well, I don't have the tools to determine the mean. Well, I will need to do some things to find the standard deviation that we're going to do in the next section, and other things to determine whether Biden was an outlier. Could be an outlier, but I haven't done the computations. So the median, if we include Biden, is 55. Just pick the middle value, and that's going to be the median. Yeah, we add Biden, Joe Biden, the median is going to be 55. Now, if you have a frequency table, you can still find the median. That's going to be, actually, yeah, this is not in the book, so I'm just, yeah, I remember writing this. So the next example is finding the median of the frequency of a frequency distribution. So in this frequency distribution, you have the value and the frequency of that value. Okay, so those are the values, and the frequencies are 4, 9, 6, 3, and 4. So when you add the total, you have 26 data values. So if there are 26 data values, the median is going to be the mean of the two middle values, in this case, the 13 and the 14 value. So there are 26. Data values. The median is the mean of the 13th and 14th value. Okay, so let's find this out. The first four values are 74. 74. The following 9, we include the end value. So from the 5th to the 13th value, 5th through 13, the value is 81. And remember, I'm including the end values. That's why it goes from 5 through 13. From 14 to 19, even though you have enough information to find the median, but I'm still going to write this, 20 to 22nd. It's 94. And the last four were 23rd to 26th. The value is 97. Okay, so the median is the mean of 81 and 88. So the 13 and 14 value, the 13 value is 81, the 14 value is 88. So the median is going to be the mean of these two, which happens to be 84.5. Okay, so to get more information about how the data is distributed or spread out, you can use the 5-number summary, which is going to be finding medians. That's on page 739. Okay, so yeah, okay, yeah. So you can see that the median cuts the data in half. So the median is the middle value, so it's going to divide the data into lower half and upper half. We now move to the concept of quartiles, which, as the name suggests, cut the data in quarters. We find the quartiles in much the same way as we could cut a pizza into 4 equal pieces. So first split the data in half, and then find the median of each half. Okay, so the median divides the data into two halves. The set of numbers below the median is called the lower half, and the set of numbers above the median is called the upper half. The median of the lower half is called the first quartile. So it's going to be the median of the first half, and it's indicated by Q1. The third quartile, denoted by Q3, is the median of the upper half. So the 5-number summary of a set of data values consists of the following: the minimum value, the first quartile, the median, the third quartile, and the maximum value. So the last example I did with the presidents, they were asking us to compare Obama's age with the ages of the presidents during the 20th and 21st century. So, and we saw that, well, if Obama was 47, he was younger than the median, indeed. Most of them were people in their 50s or 60s, a few in the 40s, and Trump, well, Reagan was late 60s, and Trump was 70. And nowadays, Biden, well, when he took over, he was 78. Okay, so consider the list of ages of the presidents from example 4. We're going to find the following for this data set: the lower and the upper halves, the first and the third quartiles, and the 5-number summary. Okay, so if we have the data, we have the data values, we have 20 values. So the upper half or the lower half is going to be the first 10 values, and the lower half is going to be the last 10 values. So the lower half is what is, the first 10 values. And the last three are 52, 54, and 54. And the upper half is going to be the list of the last 10 values. Okay, so that's 64 and then 69 and 7. Okay, actually, I'm going to do this. I'm going to put them together in one line. Yeah, so let's put them together in one line. So that's the lower half. And if I can, I will move this more to the center. Okay. So there's that. And I need to erase that. Okay. Okay, the first one was 42. Okay, so those are the first 10 and the next 10. So I'm going to do the same. I'm going to move them more to the center to have everything in one line. Okay, so now that we have that, so we have the lower and the upper halves. In part B, we need to find the quartiles. The first quartile is denoted with Q1. So that's going to be the mean of the lower half. The mean of the lower half, or the median of the lower half, is going to be 51. So you have two middle values. They are the same, and the median is 51. The third quartile is again the mean of the two middle values. The two middle values are 60 and 61. So the third quartile is going to be 60.5. And the fine number summary is the minimum value, the first quartile, the median, which we found to be 54.5, the third quartile, and the maximum. So that is the fine number summary. And finally, you can illustrate the fine number summary with a box plot. Okay, so that gives you good information. You can still see that that Barack Obama was below the first quartile, not just below the median, but below the first quartile, because most of these people were 50s or 60s. But you can also display the information graphically with a box plot or a box and whisker plot. So the tools discussed thus far in section 42 are numerical descriptive tools. That is, numerical measures that we use to describe data. We use the fine number summary to create a graph called the box and whisker plot. So the box and whisker plot is like a hybrid tool. it incorporates numerical measures in a graphical representation. Okay, so the directions are a little bit long. To construct the box and whisker plot. Luckily, in the homework, you don't need to do it by hand. You are just going to select the correct box plot. Okay, so to construct a box and whisker plot, you first need to determine the values for the fine number summary because it's a graphical representation. Next, draw a horizontal axis from the minimum value to the maximum value. Step 3, draw a rectangular box over the axis from the first quartile to the third quartile. In this case, the height of the box is not important. And draw a vertical line in the box where the median is located. Note that it might not be in the middle of the box. And last step, draw horizontal lines extending from the edges of the boxes to the minimum and maximum values. These are going to be called the whiskers. Okay, so actually this is, well, this is a lot of writing. I'm going to illustrate this with an example. We are going to draw a box and whisker plot for the last example about the president's ages. Okay, so good thing we already have the fine number summary. The fine number summary is 42, 51, 54.5, 60.5, and 70. Okay. Now we're going to draw a horizontal axis from the minimum value to the maximum value. So this is what I'm going to do. If the lowest is 42, the lowest value is 42. I'm going to draw first a horizontal axis from 40 to 70. And above that, I'm going to draw the box plot. So that's 40. And then we have 45, 50, 55, 60, 65, and 70. So step number 2, draw horizontal axis from the minimum value to the maximum value. So this horizontal axis is going to go from 42. So I'm just making a very raw estimate to the maximum value, which is 70. Okay, that was step number 2. Step number 3, draw a rectangular box over the axis from the first quartile to the third quartile. The first quartile is 51. The third quartile is 60.5. So that's going to be the rectangular box. Step number 4, draw a vertical line in the box where the median is located. The median is 54.5. It might not be in the middle of the box, but the median is going to be 50.4 or 54.5. And finally, draw horizontal lines extending from the edges of the boxes to the minimum and maximum values. Those are the whiskers. Well, actually it says horizontal lines extending, but the whiskers are going to be these ones. Or actually the horizontal, well, the whiskers are going to be this and that. So those are going to be the whiskers. And yes, we don't need this part, we don't need it. Just the line dividing the box, but we don't need the whiskers crossing the box. And that's it. So this was the minimum, the first quartile, the median, the third quartile, and the maximum. Okay, so that's the box and whiskers plot. That's a graphical illustration of the fine number summary. And the last measure of center, or the last measure of central tendency, is the mode. The two most important ones are the mean and the median. And the mode is mainly for qualitative data. For quantitative data, it's not going to be very useful. And the mode is the most frequent value, the value that appears more often. And if a value doesn't, if no value repeats, then there is no mode. Okay, so last measure of center or central tendency is the mode. The mode of a set of data is the data value that occurs most frequently. It is possible for a data set to have more than one mode. If no value occurs more often than others, the data set is said to have no mode, or if a value only occurs once. Okay, so we're doing the last example, example 7. And that's going to be it. Okay, find the mode of a data set. Okay, so we're going to find the mode for each data set. Know that in the first set, in set A, 6 is the only value that repeats, so the mode is 6. In B, we're going to have more than one mode. Okay, so we have 6 and 4, which repeat. So there are 2 modes. Two modes. Those are 4 and 6. In C, so no value occurs more than once, and there is no mode. And really, this is mainly what the mode is useful for qualitative data. So these are not numbers, but you can compute the mode of a set of qualitative values. B is the only value that repeats, so the mode is the letter B. So that's the note. That the mode is useful mainly for qualitative data. Okay, so this is it. With this, I cover section 14.2. Thank you for listening.